In our fast-paced, technology-driven world, efficiency is key. Whether you're a seasoned developer or just starting out, optimizing your code for speed can significantly impact the performance of your applications. In this series, we'll explore various strategies and best practices to enhance your coding efficiency. From algorithm optimization and effective use of data structures to leveraging modern tools and profiling techniques, we'll cover a range of methods designed to help you write code that runs faster and performs better. Let's dive in and unlock the secrets to writing blazing fast code. Welcome to Make Your Code Faster. Make your code faster, unlocking the power of pre-sized arrays. In the ever-expanding realm of big data and resource-hungry applications, optimizing your code for peak performance is no longer just about speed. Efficient code translates to lower power consumption, a critical factor for battery-powered devices, massive server farms, and eco-conscious development practices. While intricate algorithms and ingenious data structures have their place, sometimes the most impactful improvements can come from seemingly simple tweaks. Today's episode dives into a powerful technique, pre-sized arrays, that can significantly enhance the speed and power efficiency of your code, particularly when working with massive datasets. This code shows two ways to build a large collection of data. One way is like using a dynamic list. It can hold any amount of data you add, but adding more pieces of data to the list might become slower. The other way is like using a pre-sized array. It's like a pre-made box with the exact number of compartments for your data. This approach is faster for adding data, but only if you know exactly how much data you have from the beginning. The first function, generate data with a list, tackles the task of creating a collection of data objects using a dynamic list. Here's a breakdown of its functionality. A data object contains the following fields and id that is a string type. An enum season is representing the season, like summer, spring, autumn, or winter. A Boolean scene, that indicating if the data has been seen. The logic. The function takes charge with an integer parameter named data length. This value dictates the exact number of data objects that will be generated. This line declares an empty list element named data. This list will serve as the container for the forthcoming data objects. The core logic unfolds within a for loop. The data index variable acts as a counter, keeping track of the current position within the loop's iterations. It starts at 0 and increments until it reaches the specified data length. The loop's body executes repeatedly, generating a data object for each iteration. Inside the loop, a new data object is constructed with unique identifiers for each element, assigns random seasons, and potentially sets additional properties based on the element's position in the list. After crafting the new data object, it's time to incorporate it into the growing collection. This is achieved using the pushback function of the list. This function efficiently adds the newly created data object to the end of the data list. Once the loop has diligently completed all its iterations, generating the requested number of data objects, and then it returns the size of the populated list. This value informs the caller exactly how many data objects reside within the list. In summary, the generate data with a list function demonstrates the power of dynamic lists for data generation. It can effortlessly accommodate a varying number of elements, making it a flexible choice when the data size might not be predetermined. By leveraging list element and its functionalities, this function constructs and stores a collection of data objects, each potentially holding unique identifiers, seasons, and other properties based on their position. The second function tackles the challenge of creating a collection of data objects, but with a trade-off. Instead of a dynamic list that can grow or shrink as needed, it employs a pre-sized array, a rigid structure with a fixed capacity determined up front. This upfront allocation can potentially deliver a significant performance boost of around 25% compared to dynamic lists, especially for large datasets. Let's dissect its inner workings. The line of code that creates the array takes center stage. It allocates a contiguous block of memory that can hold exactly the requested length of data objects. The data pointer is then assigned the memory address of the first element in this array. Essentially, this step carves out a specific space to accommodate the forthcoming data, optimizing access for faster processing. This function efficiently creates a fixed-size array of data objects based on a provided data length. It meticulously populates the array with unique identifiers, random seasons, and potentially position-dependent properties. However, there's a crucial caveat. Knowing the data size beforehand is mandatory. There's one additional drawback specific to C++. This solution requires manual memory management. The function allocates memory using the function newArray and must deallocate it using the function deleteArray to avoid memory leaks. This adds a layer of complexity compared to dynamic lists, where memory management is handled automatically. In essence, generate data with a pre-sized array offers a compelling performance advantage, around 25% for data generation when the data size is known up front. However, it requires careful memory management and sacrifices flexibility compared to dynamic lists. The choice between flexibility and efficiency. The two functions we've explored, generate data with a list and generate data with a pre-sized array, present a classic trade-off between flexibility and efficiency for data generation. Generate data with a list. This approach utilizes a dynamic list, offering unmatched flexibility. You can add any number of elements to the list, making it ideal when the data size is unknown or might change during runtime. However, this flexibility comes at a cost. Adding or removing elements from a list involves memory management overhead, potentially impacting performance by up to 25% compared to pre-sized arrays, especially for large datasets. Additionally, this approach might have slightly higher power consumption due to the dynamic memory operations. Generate data with a pre-sized array. This approach leverages a pre-sized array, a fixed-size structure defined up front. This upfront knowledge of the data size allows for efficient memory allocation and direct element access by index. The result can be a significant performance boost of around 25% compared to dynamic lists, particularly for large datasets. This efficiency can also translate to lower power consumption as the CPU spends less time managing memory during data generation. However, there's a catch. You need to know the exact data size beforehand. The takeaway. The choice between these functions boils down to your specific needs. If flexibility is paramount and the data size might fluctuate, generate data with a list is your first choice. But if you prioritize performance and power efficiency, and the data size is known up front, then the solution of generate data with a pre-sized array shines. Thanks for watching this episode about Make Your Code Faster, unlocking the power of pre-sized arrays. Feel free to reach out by email if you have any questions. Next episode is about reusing complex calculations. See you in the next video.